Everyone, I just came across this LinkedIn post by Mohammed Goshe. He is a PhD candidate at the University of Jerusalem. He did some research work some time ago with Believer Meats. I'm thrilled to share our latest publication in Nature Communications, a collaborative effort with my PhD mentor, Yaakov Namias, and our exceptional team at the Hebrew University of Jerusalem. This work introduces a groundbreaking approach to producing whole cuts of meat using novel metamaterials and injection molding technology, offering a scalable, cost-effective alternative to 3D printing. As we can see, here's Professor Namias. He does work at Believer Meats. The journey started years ago during a conversation about the limitations of 3D printing for creating complex meat analogs. So just looking a bit more into the abstract of this article, they're trying to mimic whole cuts, which constitute 54% of the global market. This is challenging due to the lack of scalable technology. Injection molding is a massively scalable technology developed for the polymer industry. They're using two injectable materials, a fat composite and a meat analog produced by low temperature extrusion. It looks like here they're using mung bean because it can stabilize that fat gel and mimic the mechanics of animal tissue. Low temperature extrusion produces fibers and mimics muscle. These materials can be injection molded into various whole cuts from chops to T-bones. Blinded taste tests indicate 43% preference for this plant-based steak analog. Economic analysis shows injection molding is more cost-effective than 3D printing, costing $9 a kilogram compared to $38 a kilogram. Here are their meat as well. We can see on the top right-hand corner, it looks like they have a pork chop, and on the bottom, it looks like they have a T-bone steak. Again, just like the 3D printing we've seen from Stakeholder Foods, here's another technique. We'll see how all of this eventually makes its way, if it makes its way to the world of cultivated meat. They're saying that 3D printing produces materials relatively slowly, depositing one fiber at a time. That 3D printing process is inherently limited to the rate of deposition of fibers with a diameter ranging from 0.1 to 1 millimeter, requiring high-resolution motors and technical expertise that further limit process scalability. So something to keep in mind if you are investing in Stakeholder Foods. We may have other technologies that are better in the long term. This has also been applied to plant-based meat. We don't know yet how and if these technologies will be similarly applied to cultivated meat or if they will need other ways of creating that texture. In my last video, I mentioned that I was away tasting cultivated meat, and I actually was trying the wild type cultivated salmon. I'll say two things. First, their meals are very well done. They are doing a tasting series throughout the US this year, so go check out their Instagram or sign up on their website. I was at a Japanese meal. It was cool how they presented their fish. They had a grilled salmon, they had a wild caught sashimi, and then they had wild type sashimi. So you're able to compare how the cultivated fish does compared to wild caught salmon, which is very cool. The other thing I will say is that the biggest takeaway for me in terms of where the technology is today is the taste and the flavor is there, maybe slightly lighter than other kinds of salmon. You very much know that you're eating salmon, but the main challenge I think right now is working on texture. The texture of the wild type salmon was softer than the wild caught salmon and the grilled salmon that I had. It's cool to see some of these developments that are happening with different companies that are working on texture. Thanks as always for watching. We'll catch you in the next video.